All right, guys, for 1.7, this is what I see here. If I saw this, this is what I would do. The reference angle, 236 degrees is, when they say reference angle, they mean, can I picture this as being a triangle? A little special, or like a right triangle within the unit circle. So let's find 236 degrees and see if we can figure out what the triangle would look like and what angle the little theta is that's around the origin. And so that's what they're talking about here. 236 degrees. Let's see. We know this is 90, and then there's 180 there from another 90, and then this is like 270. So we're pretty much somewhere between 180 and 270. And of course, this would be 360 or 0. I'm not going to put a comma. I don't know, just whatever. Anyway, so 236 degrees is 180 and then a bunch of extra, or 270 minus some. And so let's see, if I were to think 180 plus, I think an extra 56 degrees gives you that 236. And so I'm just going to, you don't have to draw it well, but what I'm seeing here, guys, is 236, that's past 180. So remember how we draw our angles. If I'm going to think of this as a reference angle, it's always going to be this angle that's coming off of the x-axis, and you draw your x-axis first and then go straight down to get to it. It's never coming off of the y-axis and then making some angle there. It's definitely always the angle off of the x-axis. So if I can figure this out, this is 56 degrees past 180, I believe, is 236. So this is 56 degrees right here. That's the reference angle they want to know. You could certainly figure out also 270 minus something makes 236. But at that point, what's really going on is you're figuring out the angle that's right here off of the y-axis. That's not the one that they want. So really what you're better off doing is always comparing these angles, your reference angles, as being taken off of the x-axis, either off of the 180 side or off of the 0 and 360 side, and then just plus or minus from 0 or 360 or 180, and then figure out how many degrees you are off of 180 or off of 360 or off of 0. Anyway, that's what I'm looking at here. So for this one, I'm 56 degrees, it looks like. So another one, if we did a weird one, negative 142 degrees, let's see where that would go. Negative 142 degrees. Well, that's actually going to be at a similar spot, it looks like, because negative degrees go down. And so this 270 is also known as negative 90, right? It's 90. And then another negative 90 is negative 180. So we're not quite there. So if I were to say negative 142, that's most of the way, but not all the way to this 180. And so, you can estimate it if you want to be like, well, there's 135 negative or something, or else you don't have to do it real accurately. If you don't know this stuff that well, or if you just don't feel like it, just draw something down in the right quadrant. Then we'll figure out the numbers to verify what we need about it. And so I need to figure out, okay, I've drawn this 142 degrees, and you can even draw it as you go so you don't get lost and then be like, this is where 142 is. It's going down and all the way over to there. That's 142 degrees. The reference angle that they want, though, is always the one that we can find in a little right triangle that's coming off of the x-axis from either the 180, or if it's on the right-hand side, from the 0 or 360. So we're coming from the 180, and then in this case going again down, not up. And we need to figure out this little theta that's coming off of the origin from the x and then the y. And so let's see if we can run numbers like that. There's different ways people do it. What I'm seeing is that 142 is most of the way to 180, but it's not all the way, of course. So if I were to figure out how close 142 is to 180, I could minus the two of them, and it'll tell me how many degrees there are here. That's certainly not the only way to do it, but that's what's coming to mind for me right now. So I'm going to do 180 minus 142, figure out how many degrees are left here, but there's other ways to do it. If you want to do 90 plus something makes 142 and do some kind of a weird figure in there. Nothing else is coming to mind for me right now that sounds real efficient besides this 180 take away 142 thing, but you might think of some other way, there's always multiple ways to do this. Anyway, so then 180 minus 140 would be 40. So this looks like 38 probably degrees. And then looking good. And remember, if we're talking reference angle, it's never a negative angle in there. Well, actually, it depends on how they're going to define that and what they're looking for. I would never consider it to be negative because it's a reference from a right triangle. And so that's always just regular degrees if we're talking about it being in a right triangle. But here, let me stop the annotation and see if they disagree, if they're coming from a different perspective. Let's check their answer. Yeah, they agree with me. So 38 degrees, because we're not thinking of it as an angle of rotation when we're talking about reference angles. We're talking about right triangle trigonometry. And so they're in agreement with me on that one, and that's good. Okay. Oh, I should probably get rid of this stuff. Here, look at this, guys, while I get rid of this. Questions 2, 3, and 4 on mine have all the same numbers. What the heck, you know? I mean, there's only certain numbers they're going to choose, but I'm hoping these are not algorithmically chosen to just always be the same. You know, I don't know. Let me know if that's the case. I'll change it for the next class or something. But anyway, so find the exact value. What's going on here is you can do this by reference angle, or at least by finding, you know, a coterminal angle that's within the first 360 on your unit circle, you know, or you could certainly do it by reference angle, making it something that's in a side of a triangle. But definitely we need to wind these numbers down no matter what. And so we're going to have to figure out something coterminal. And then I think after that, we'll just go with unit circle angles or something like that. Sine of 1290. And so 1290, I'm going to, okay, that is a 3 and a 2 all at once. Okay, 1290. I'm going to figure out how many 360s go into that, you know, and then we'll do that from there. Let me pause this for a second and run some numbers on that. Okay, I divided that while I was on my little break there. It turns out that it's a little bit over 3. It's like almost, it's a little over 3.5 actually. 3 point blah, 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 you know, 3-point mess. Anyway, so there's 3 times around, it looks like 3 360s in here plus some extra. So we got to figure out how much extra. So if we did 360 times 3, well, that ends up being 1080. And then we'll minus that like we do 12 here, since we're trying to be quick. 1290 minus 180 ends up being 210 degrees, or 1080 rather. It ends up being 210 degrees left over. So we're 210 degrees past the, past that last revolution here. And so to diagram that, what we're saying is, once again, we're like 1 around, 2 around, 3 around. That's 360, then 720, then 1080. And then an extra 210 degrees is what they're saying. So in another color here, I'm going to do the extra 210 that's past the 180. And then an extra, 30 degrees past 180 is 210. So if we're trying to picture this, that's kind of what's going on. And so what's most important about this is that we're recognizing this as being 30 degrees past 180. We can do it by reference angle there, or even just by unit circle, at noticing that since that is 30 degrees past 180, 210 is going to be a popular unit circle stop. And so I'm going to do this just by a little figuring here, but we'll also look at the unit circle to verify what's going on. If that's only 30 degrees past, because 210 minus 180 is 30 degrees, so that's only 30 degrees past the 180. What I'm thinking here is that means if it's a 30-degree angle, it's a lot over and a little bit down. So that means the big amount is going over to the left negative. That'll be the radical 3/2, negative radical 3/2. And then it's down 1/2, that's the small part, and also negative. So let's see if we can figure out the sign value. Well, the sign value is the up and down value. So that should be a negative 1/2. And then radical 3/2 is the cosine value, also negative radical 3/2. Boom. You can put a radical 1 on there if you want them all to have a radical, but whatever. Anyway, alternatively, look at this. Here, let me get rid of all that mess. Clear the drawings. Here's a copy of the unit circle. There's our 210 degrees. You might want to ignore the whole 7 pi over 6 for now. We're not dealing with those yet, but here's our 210 degrees. Here's our x and y, also known as our cosine and our sine, And so then here's our sine value is negative 1/2, because of course it's going down just a little bit. And then our cosine is the big one. So it's going over a lot. And so it's radical 3/2 negative. Anyway, so you can just look them up in that way, and they'll say, what's the cosine at 210 degrees? Oh, negative radical 3/2. What's the sine at 210 degrees? That's negative 1/2. Works like a charm, looking good. Oh, I'm still annotating things. Okay. Boom. All right. Now, next thing that's how those go. And then for question number 5, very similar idea, but let's go ahead and make sure that we're on the same page here. For question number 5, they're asking for cosecant of a weird angle. So let's figure out the weird angle best we can. And then cosecant, let's remember that's upside down sine value. So just a quick prescription on this one. Once we do our magic to find a nice angle on this, that's somewhere between 0 and 360, or at least a reference angle or something, then we will probably, I'll just go ahead and find the sine value because we're used to that. And then we'll just upside down it for cosecant is what I'm thinking. Anyway, so negative 630, that is not quite 2 full revolutions, because remember 360 is once around and then 720 is twice around. So this is less than 2 times around. So we got 360 plus some extra. So we're looking at, now of course these are negative degrees here. So we're rotating a funny direction. I say funny, it's actually clockwise, but whatever. Anyway, and so what was I gonna do? Oh yeah, negative 360, boom. And then I don't know how much further I need to go to get to 630. So let's see, how much past 360 is 630? It's not a full second away. So maybe I'll just minus it and see. If that were 630 minus 330, we'd have 100. So I'm thinking this is, or sorry, we'd have 100. We'd have 300. So I'm thinking this is 270 or something like that. Looks good. And so then I guess I could just borrow and make sure. But anyway, so then we're once all the way around going clockwise, negative degrees going downward. Let's call it downward because clockwise is 2. It seems positive. Anyway, so then downward 360, then downward another 270. And so you might recognize 270 as being a multiple of 90, and it will be. So this is negative 90. You know, we're going past that. And so here, I'll even change colors. There's our first 360, and then we'll go another 90, another 180, another 270. That's where we are, straight up. And that's all we need to know. Where did we end up? Straight up. You could think of this as negative 270 degrees, or you could think of it as positive 90 degrees. You know, since it's going straight up, we don't have to do a whole lot of math to figure it out. We know that that's a positive 90, you know, but you could do math to figure it if you like and say, well, that's 206 or 270 that way. A full 360 would have been there. So I could do 360 minus off 270, and that'll tell me how much big this is. But that's 90, as we know. And so this is a 90-degree thing. And we want to know, what is the cosecant value straight up, you know? Well, we know the cosine value and we know the sine value. Cosine value is the x value, that's 0 because we're right in the middle. The sine value is the y value, which is 1. And so then if we had sine value being a 1, remember what that looks like as a fraction. It's 1 over 1. And so then the cosecant is an upside down version of that fraction. So that's also 1 over 1, you know? And so that's just 1, I guess, you know? Same idea with these ones, you know, find yourself a small reference angle and then figure out tangent and cotangent. Remember, tangent is the opposite over the adjacent, and there's a cheater's method for that. So without getting into the whole thing about let's find the angle, if we had to do the tangent on, say, any one of these things, remember how tangent goes. It's the opposite over the adjacent. It's also the sine over the cosine. So if I had to do the tangent over here, since we already did those numbers, tangent at negative 630, say we had to do that one like we have to do down there. Well, tangent just goes, it's going to be the sine over the cosine because it's the opposite over the adjacent, you know, or the y over the x or whatever else. You know, it's the sine over the cosine. And there's actually an identity about that, but it's the y over the x here. And so that's 1 over 0. So the tangent at negative 630, we know it's straight up. And so we found our coordinates on the unit circle. And again, you can just use the unit circle for it. And that's going to be a 1 over 0, or also known as undefined, or you can just put does not exist. D and E is the way they like that, you know. And then cotangent is, of course, upside down of that. So that's 0 over 1, which should be equal to 0, you know. That's how you would figure these ones. They may not be at a perfect 90 like this, but you can certainly do, look up things, you know, figure out where you're going to end up with a reference angle, or at least something small coterminal, and then look it up in the unit circle. And you could, you know, you can always just look up a unit circle until you get used to them. I'm still annotating. There we go. You can always just look up a unit circle. This is from embedded math, as you might be able to tell. It's a really good one. But at some point, you'll be, well, the goal is that you'll be comfortable enough to do this yourself, you know, and just kind of make your own unit circle or whatever. Okay. Oh, here, let's see. Anything else we got to know? Let's see how intricate this is. Maybe this is worth going over as well. Here are all my drawings. If there are any left, there was a tiny little speck on there, you know. Anyway. Okay. So we've done, actually, you know, we've done these kind of before. So we'll just do a quick preview on this. Remember, we saw this in 1.6 as well, but I don't mind going over it again because they're weird. So we have the tangent is, what I want you to do here, guys, is this. Before we even look at the particular values, just notice that the tangent is negative and the sine value is, if it's less than 0, it's negative. So let's see what we can do about that. If the tangent is negative, that means it's the opposite over the adjacent, or this is the y over the x is negative, meaning we have essentially it's a y value and an x value that we're dealing with here, or a sine over a cosine. And if the whole thing is negative, that means one of them is negative, but not both. So that already narrows things down because it's not going to be over in quadrant 3 here, because over here, things are both negative, you know, and it's not going to be in quadrant 1 over here because there's no negatives there, you know. So definitely one of them is negative, but not both. So we're already down to, because of that tangent conclusion, we're either in quadrant 2 or quadrant 4. The other ones are out. And then now that we have it narrowed down, the sine value is less than 0. So that means the sine value or the y value is the one that's negative. We knew it was going to be one of them. Now we know it's the y value that's negative. So that means quadrant 2 is out. We must be down here. We must be downstairs, because if the y value is negative, we must be down instead of up. So we're in quadrant 4. We have now determined, you know, those are out, those are out, those are out. We are in quadrant 4. So now we're just going to draw a basic generic angle in quadrant 4. I'm not even going to look at the scale on this or look at those numbers, although I just go and set them again. To try and make it look nice, I'll just draw an angle down in quadrant 4. And then remember how to draw our triangles. We go over first from the axis, the x-axis, and then go down or up from there, in this case, down from that x-axis. And then we'll draw our angle. This theta will be right from the origin right there, between the x-axis and your funny hypotenuse radius looking one. And now let's label them out. We know, we don't know much about the sine value, but we know that the tangent is the opposite of the adjacent, or you can think of it as the y over the x, or any other way to think of it. It's the opposite, which is over here, over the adjacent, which is this one. And we know that it's negative 4/3. And we know, well, here, let's just put it here. 4/3 is 4 is the opposite. Remember, that's opposite over adjacent. So the 4 is the opposite. The adjacent is the 3. And then we don't even have to guess about which one is negative, because 3 is going to the right. So that's not. So 4 must be negative. And now we have a good drawing going on. We can do Pythagorean theorem. You know, a squared, b squared, c squared. This is probably just be a 3, 4, 5 triangle is what it looks like. By the time you do Pythagorean theorem, this will probably be a 5. And then just start going to town on all these ratios. Opposite over hypotenuse, you know, la, 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 la. That's what I'm seeing on this question. Oh, what I did it again. I thought I was stopping the recording.